So find the integral of 5x minus 3 to the minus 1 dx, so it's with respect to x, given that 5x is greater than 3. I'm going to say we ignore this. It's to do with what the answer is, and it's to make sure that the answer is a real number. But let's just ignore it. In general, unless you're aiming for the full-on 100%, we can ignore stuff like that. But obviously you might come back to it later if it became important, because you were trying to find out a value for x or something, and you found 3 values. Anyway, let's do this. I'm going to use my standard approach. Is it one of the 5 standard things? No, it's not. Is it on the formula sheet? No. Is it something divided by something else? So is it f dash of x over f of x? Well, actually it is. But let's just pretend that we didn't see that. Let's pretend we didn't see it, in which case it's either parts or substitution. I think it's quite obviously a substitution, because there's something that's inside. So let's write u equals 5x minus 3. So I repeat, it is actually a type 3. You could solve this straight away if you spotted that it was a log, but let's pretend we haven't. So then u equals that. Let's find out what du dx is. That would be 5. Okay, that was easy. So that means that dx equals du over 5. I've just done that in 2 steps, which is very dangerous. Feel free to do an extra step yourself. Right, so then that becomes the integral of u to the minus 1 du. Okay, so now we revisit number 1. Is it one of the standard ones? Yes, it is. That's great. The substitutions work because it's turned it into something we can integrate. Make sure we realise that it's 1 over u du. By the way, has anyone spotted my deliberate mistake? I should have put du over 5. So let's just put a fifth outside here. So then that's 1/5 ln u with the plus c in front. Is that the final answer? Debatable. Really, we should put the x back in. And in an exam, that's definitely going to make sure we get the full marks. Now we've put the x back in. That's the final answer.